RockSim-Pro makes it easy to select rocket motors that will work in your rocket, but now we want to fine-tune things. So previously we had gone through the recommended motors feature. Now we want to take and look at specific rocket motors. For example, say we have this Avion rocket, and I'm looking at the S-C6 right here, and if you, from this previously run recommended simulation, we see that the rocket goes 828 feet, and we have a recommended delay and an optimal delay. So many people ask, what's the difference between optimal and recommended? Optimal means when everything goes right. The recommended delay is we understand that rockets don't always go straight up. And if they aren't going to go straight up, then we need to use a delay that's slightly lower. So the recommended delay will always be the optimal delay that's been rounded down to the nearest integer. So 5.5 rounds down to 5.0. Now we want to load this motor into RockSim, and an easy way to do it is you can select the motor in the chart and then do a right click with your mouse and say load engines from the menu that pops up. This now loads the rocket motor, and if we go to the prepare for launch screen, you'll see that the S-C6 has been loaded into the rocket itself, and now we can start going through more fine-tuning, which are these tabs right here. So under flight events, we're going to select deploy at maximum engine ejection delay, and the engine ejection delay is this number right here. And so what that means is 5 seconds after the motor burns out. So this is not measured from liftoff, it's measured from when the propellant is done burning. And this is true for all rocket motors. So we have it set to deploy at maximum engine ejection delay. We'll go to the starting state tab, which is where the rocket is sitting on the launch field, so we can see our launch guide length. So this is the length of the launch rod, and since this is a small rocket, I'm using a 36-inch rod, but you can always use something that's longer, and it's always recommended. If you have a longer launch rod, use it. Our next thing is our launch guide from vertical, and this is in degrees, so straight up is 0 degrees, and then we can go to the left or to the right, and I recommend always going towards the right because it affects the launch guide azimuth. The azimuth is the compass direction. So imagine this wheel right here is a compass where north is straight up, south is down, east is to the right, and west is to the left. So if I change this to 90 degrees or something close to 90 degrees, I'm launching towards the east. So if you type a number in here, make sure you hit the tab key so that it accepts the value. So I'm launching towards the east at a 44-degree launch angle. But if I change this to a minus 44 degrees, what that actually does is now I'm launching towards the west. So if you don't want to get confused, always make sure that you're on this side of the dial, launching with positive numbers. And typically you'll want to keep your launch rod below 30 degrees, and this is the NAR safety code. So under 30 degrees is an acceptable launch angle. Ignore simulation controls right now. Under launch conditions, this is where on the planet our launch pad is placed. There are a number of launch sites that are already pre-saved, so if you go to choose from launch site, you'll see a list, and these are mostly NAR and Tripoli clubs around the country, and it will say that it's either NAR or Tripoli, and then you can select one and click OK. And what that does is it updates the altitude of the launch site above sea level, as well as the latitude and the longitude. Now it doesn't really affect the humidity, temperature, and barometric pressure. For now, I would just leave those alone. If you want to add your own launch site, you'll need to put in the altitude, the landing zone altitude, and they're different because it is possible to launch from the top of the mountain and actually land at a lower altitude. And it's also possible to launch the rocket from up in the air, such as from a hot air balloon or from an aircraft. And you can set that altitude right here. And then also you will need to know the latitude and longitude. Now these are a little bit harder to figure out, but you can get this information from Google Earth or from the launch visualizer at RockSim.com. That's a good place to get the latitude and the longitude of your launch site. Wind table, I have a different video explaining how to set wind in RockSim, and for right now we'll leave uncertainties alone. And at this point we've selected that C65. We have a starting state, or we have a flight event where it's going to deploy at parachute maximum ejection delay. The starting state, we're launching at 28 degrees towards the east, and from this launch site here in California. So when we hit flight profile, we will see what the rocket will look like. So this is the launch visualizer, and it's showing us the rocket sitting on our pad, and our pad is actually below the ground right now, and I have another video that explains how that happens and what you can do if you actually want to see the launch pad above the ground. But for right now, I want to zoom out and just kind of get the lay of the land and see where the rocket is being launched from. So I'm obviously in a desert right here. It looks like to be a dry lake bed. This was in California, so that makes sense. Down here is our compass, and I'm going to switch it around so north, which is the black arrow, points up, which is typical. And your rocket will be right here in the middle of the screen, and if you lose it, you can either hit the home button or you can use the plus and minus to zoom in and out to find the rocket. Alright, so my rocket's sitting on the pad, and as we discussed, we have the rocket angled at about 28 degrees towards the east. So east is on this side of the screen, so we are oriented properly. I'm going to zoom, I'm going to go to actually a trajectory view so that our launch site will stay oriented properly. And I'll zoom in just a little bit. And then I'll click the launch button, and we can actually see the flight. So we can see the launch pad was down here, we see the tracking smoke coming out, and we see the rocket taking off. This dot right here is our apogee point. The dot is red, which is an indication that the rocket went too far away from the pad. We want this point to be inside of this weathercocking cone. So I would classify this as not so good of a launch. We would need to adjust the launch to make sure that that apogee point stays within the cone. But we can see where the rocket's going and where it's going to land. And I'm going to just take the slider and just move this around and just kind of reoriented things. So it launched right here, it went this way. Once the parachute opened up, it started drifting down towards the north. So that gives you an idea of how to fine-tune your launch so that you get the best and most perfect flight for your situation.